and we'll get started here. Okay, so oh, this is a typo. It should say 102C. That's our class, Monte Carlo methods, and we'll start. I think you guys all know how to use Zoom, right? Is anybody here like a brand new UCLA student? Like you just transferred in or something? Okay, so all of you were here in the spring and you already had to use Zoom. So, but anyway, I think, so we have the participants panel. Okay, so you guys are all muted. A lot of you have your videos on, which is great. And of course, if you need to turn off your video, a lot of you have figured that out. We have the participants panel where you can give me yes and no feedback, which is always helpful during the thing. Or you can also use your reactions, give me thumbs up. Zoom has expanded so that you can now have party emojis, right? I don't know, anybody want to give me a party reaction emoji? Yeah, there you go. Woohoo. So thank you. Exactly, right? Yes, this is the epitome of Zoom party here. So there we go. Okay, and so anyway, that's what we can do, and you know, as I go through, you can give me yes and no feedback as well. And then I think a lot of you have figured out, you know, how to use the chat to either ask questions. I think, you know, I was worried about like chaos and stuff, but I think most of you can be fair. It's not going to be too much. So feel free to, you know, unmute yourself and ask a question if you need to. And that's fine. You know, if it gets too chaotic, then, you know, then I'll say only questions only in the chat. But I imagine that's not going to be too much of a problem. So, so if you feel like unmuting yourself to ask a question, go ahead and unmute yourself and ask a question. That's no problem to chime in with your thoughts and stuff. Okay. And I think, you know, I want to encourage you guys. I think you guys are able to set up your own Zoom meetings and whatnot. I don't know, are you guys able to have like unlimited Zoom meetings, or are you still limited by like the 40-minute? You guys get unlimited stuff? Maybe? Okay. Well, anyway, yeah, try to keep up your friendships and stuff. You know, all relationships, whether it be romantic or platonic or just friendships and things, everything requires investment, right? Like if you don't invest any time in your friends, then they're not going to be good friends. And but if you want to maintain strong bonds with your friends, you got to at least talk to them every now and then. And so anyway, set up some Zoom meetings and just have a chat, even if you don't have like a purpose behind it, just to kind of talk. And then maybe you'll realize, well, you know, we don't actually have a lot in common. But hopefully that won't be the case. All right, I think this is what I put in the syllabus. Office hours, this is my plan for office hours. Thursdays from 3 to 4 p.m. and Fridays, so that'll be today, from 1 to 2 p.m. Also by appointment. I think I'm going to plan on having like office hours Saturday morning as kind of just a catch-all for all of my classes. So that'll be, you know, 102C, but I'm also teaching a bunch of other classes. And so that'll just kind of be a catch-all for that. And then, you know, you're allowed to address me as Miles or Professor Chen or Dr. Chen or whatever you're comfortable with. And that's all. You know, just one thing that always kind of annoys me is when people write emails without any kind of name or address. So that's that. Okay. I'm going to be using two textbooks. One is called Doing Bayesian Data Analysis, and the other is Introducing Monte Carlo Methods with R. Both of these textbooks are free. You can download the PDF for free as long as you are connected to the UCLA VPN. Okay, so if you click, right now I'm not connected to the VPN, so if I click this, I'm not going to be able to download the book. But if you are connected to the UCLA VPN, you should be able to download a PDF of these books for free. Okay, because your tuition money goes to pay, well, it goes to pay part of my salary, and it also goes to pay the UCLA library, and the UCLA library subscribes to a bunch of these online resources. And so, so that gives you access to the PDFs of these textbooks, which is also a big reason why, you know, I know students sometimes wonder, like, why is two-factor authentication so important? Like, I'm a student, who's going to hack into my grades and stuff? Well, part of it is that two-factor authentication gives you access to the UCLA VPN, which unlocks a whole lot of stuff, and a lot of the fact that your computer says I have a UCLA IP address will give you a lot of resources like these books and stuff. So the UCLA VPN is a powerful thing. So anyway, you can get these textbooks, download the PDFs for free. This is my grading plan. We're going to have viewing quizzes, lecture viewing quizzes. And so if you were in my class in the spring or in the summer, we did lecture viewing quizzes. This is what I'm going to do instead of attendance, because I know not everybody can attend live. But I do want to make sure everybody watches the lectures. And so during the lecture, I'll kind of be dropping quiz question answers, and you'll just answer them. Okay, so so this first quiz, I still have to actually create it on CCLE, but the first quiz, the first answer is going to be E as an elephant. So if you have a piece of paper, just jot that down. Your very first quiz answer today is E as an elephant. E as an elephant. That'll be the first one. And then I'll give you the other ones as well. And I have 2 lectures of this. I've got a lecture at 10 a.m. and a lecture at 11 a.m. Both lectures are pretty much the same, and both lectures will have the same quiz answers. So if you need to swap, if you want to attend one or the other, then that's fine. Okay. So that's kind of the plan. We're going to have homework assignments, and I'm planning on having them worth 27%. We're going to have 3 exams, exams 1, 2, and the final exam. And details regarding the dates on those are in the syllabus. And I'm currently planning on doing them, you know, live, proctored via Zoom, submit via Gradescope, and have an exam at 10 a.m. and 10 p.m. It seemed to have worked fairly well in the spring, and kind of a modification of that seemed to have worked fairly well in the summer as well. So that's the current plan. And if things need to change, we'll adjust them. How long will the midterms be? Still figuring that out. Okay, so but I'll give you a heads up and well in advance, just in case you need to adjust something. So so yeah, again, the exams I'm planning on doing at 10 a.m. or 10 p.m. So I know you guys are meeting here at 11 a.m. So just be aware on exam days, you'll either have to come in earlier at 10 a.m. or come later at 10 p.m. And hopefully one of those times will work for you. Okay, and then Campus Wire is set up. There should be a link in the syllabus, and if not, if I haven't put it on CCLE, I'll put it up on CCLE as well. There should be a link for you to participate in Campus Wire.
For the homeworks and Campus Wire, will both of your lectures be the same?
Yeah, it'll be the same. So both lectures will just be in one giant Campus Wire thing, and it should be fine. Okay. You know, and on Campus Wire, there might always be a couple students who are very quick to answer everybody's questions, and you know they're going to achieve Eagle status in like the first 2 weeks. don't be discouraged, okay? You can always contribute more to the conversation, and be generous with your upvotes, okay? So in Campus Wire, you can upvote each other's answers. It costs you $0 to upvote someone else's answer, and if you feel like it's a good answer, just give them an upvote. It costs you nothing. Be generous. It feels good to get upvotes. There's okay, maybe there's a psychological dopamine hit that you get when you get an upvote or a like and things like that, and perhaps that's breaking our society because of but anyway, be generous with the upvotes, and don't hesitate to just answer or just add to the conversation, even if somebody else has answered the thing. Okay, and it's okay to give what we can call top level answers, even if it's like in response to something else. You don't have to, because you don't get any points for continuing the thread like super deep. So you can kind of game it. It's fine. Okay. My hope.
Campus Wire with the other section.
What's that?
Like the Campus Wire, are we having the same page as the other?
Yes. Yes. So I've got 2 lectures, and I'm going to put both lectures in the same Campus Wire, just because sometimes a good question will get asked in one, and I want the answer to that question to benefit both lectures. Okay. Okay, grading scheme. I always use a straight scale. I never curve. Like, I've got kind of personal philosophy feelings about that. So anyway, this if you've taken a class with me before, this should not be a surprise. And if this is your first class with me, then this is just my policy here. All right, so the way lecture viewing quizzes work is it's just going to be a very easy quiz. I already gave you the first answer, which was E. I'll give you the second and third answers later in today's lecture. And this is just to kind of make sure you watch and you pay attention to the lecture, and also to prevent you from falling super behind. With an online course, because I've taken online classes, and I'm aware of at least some of the pitfalls that were struggle for me. And one was, it was easy to just not attend lecture and have a whole bunch of lectures just kind of accumulate, and I would have to like catch up on 5 or 6 lectures, and that was completely miserable and terrible. It's kind of fun to binge watch TV series and shows. It's absolutely miserable to try to binge watch a series of lectures. Okay, even if it's like a super fascinating lecture series like statistics, but it's not fun. Okay, so a little bit during multiple times during the week, like 3 times during the week, the schedule is much better. So anyway, that's what these lecture viewing quizzes are for, is to kind of keep you on pace. Each quiz is only open for a couple days, so make sure you take the quiz while they're open. Okay, I will drop the lowest quiz. All right, so if you forget to take it one day, that one will get dropped. Okay, but more than that, then you'll start losing points. Okay. We'll have homework. Homework is, I've got kind of this weird homework policy. Generally, I make them due at 6 p.m. California time, and basically you get a 10-minute grace period. After 10 minutes, you basically lose 5 points each hour, but then the penalties stop at midnight. So, and then they resume the following day at 6 p.m. And so you'll get, and if you need an extension on the homework, you can just submit documentation, and I'll give you a 72-hour extension. You don't have to like email me. If you've got documentation, you don't have to email me. Okay. If you need an extension and you don't have documentation, then come talk to me. I generally try to be reasonable and flexible within reason, because I know life can happen. So, but all of the details regarding this will also be in the syllabus. So anyway, make sure you read the syllabus, I guess. Office hours. Come to office hours. I like it when students come to office hours. Okay, I'm very happy to answer questions that people have. I'm very, if you have questions about grad school and stuff like that, I'm happy to talk about those. you know, and if we make mistakes in grading and you need points back, that's totally fine. Okay. The only kind of office hour thing that I don't like doing is like maybe on an exam or on a homework problem, you made a mistake and we decided to deduct 10 points for the mistake, and you feel like, oh, that was harsh. You know, you should have only taken off 5 points or something. I don't want to get into a fight over that. Okay. We try to be reasonable in terms of how many points we take off. Sometimes it will feel harsh, but we'll often have a reason for that. And I just don't want to have to get into an argument over why your mistake was worth this many points and not this many points and things like that. So but sometimes those happen. Okay. There is a lot of homework and the homework assignments. If you've taken a class with me, I think you know my homework assignments can be fairly long, and that's by design, and it's to give you guys coding exercises to make sure you do a lot of coding. And so in order to graduate UCLA, you have to complete what they call the Writing 2 requirement, and that's because UCLA, I believe, rightfully believes that writing is an important skill to have, and so you have to take courses. There's a whole bunch of different courses with different subjects, but basically, if you take a Writing 2 course, you're going to be writing a bunch of essays, and you can think of this class as kind of like a coding equivalent of a Writing 2 class, and you'll have to do quite a bit of coding, and I believe that's important if you're going to be graduating with a degree in statistics, because pretty much everybody's interactions with data these days involve code. Gone are the days of just using tables and getting away with just using Excel and things like that. Okay. We, anything larger than a couple thousand rows, which is a lot of data sets these days, is going to require the use of code. And so I think it's important that we learn how to write code. So lots of this. Okay. I'm going to talk a little bit about academic integrity and plagiarism. Please bear with me if you've already heard this spiel before because you've taken a class with me. I'm just going to repeat it again, but it is, I feel it's something that's important for me to kind of state, because I understand, what it's like. I remember, it's been a while, but I remember what it was like to be a student too. So, a lot of the homework assignments, a lot of the tasks that I assign in the homework, there's already going to be code solutions available, code that exists that is high quality and highly functional, and they're going to help you accomplish whatever task it is. Okay. But what's important is that in this class, the point of these homework assignments is not that these tasks get accomplished. Okay. Like, I'm going to have you write up some code to, create a random sample from some particular distribution. And for me, the important thing is not that we get a random sample, but the important thing is that you work through the exercise. Okay. And I like to compare this as going to the gym. And, if you go to the gym to lift weights, the point of going to the gym is not that these heavy weights get lifted. The point of going to the gym and lifting the weights is the actual process of lifting the weights. The process of lifting the weights is difficult. It tires out your muscles, and after kind of tiring out your muscles, your body will rebuild those muscles so you get stronger. And similarly, the point of these exercises and homework assignments is not that whatever task in the homework is accomplished, but just that it makes your brain a little bit tired so that later on your brain will kind of make new neuron connections and you become a better coder. And if you go to the gym and your workout was not difficult so that your body didn't have to work hard at all, you can't expect to make any kind of progress or see improvements or gains. And similarly, if your mental exercises present no mental challenge to you, your brain is not going to see the need to make any kind of new connections. And it's that process of struggling through a coding assignment that is going to force your brain, or encourage your brain to make new connections to get better. And that's the point. That's the whole point of all of this. It's not fun to struggle. It's exhausting. You get tired afterwards. But that's what we want. Okay. And if you copy someone else's code, or if you take a peek at the answers of someone else's solution, that's a bit like having somebody else lift the weights for you. Okay. And if the goal was to get the weights lifted, then you've accomplished that goal. But that is not the goal. The goal is not to have the weights lifted, but the goal is to go through that process to get stronger. And similarly, the goal is not that the homework assignment gets completed, but the goal is that you have gone through that process to make your brain stronger. And so, I really want to kind of just encourage you through that process of working through the assignments, to challenge yourself so you get better. And, I recognize that, when it comes to grading and stuff, like I have to kind of grade on the finished result, because I don't have the time or resources to just meet with you one-on-one and just kind of see how much learning and progress you are making. So, we kind of have to grade based on the homework, but I'm hoping that you can evaluate your success based on what you have learned, and not necessarily, how much, what kind of letter grade that you've done. Okay. And so, I don't want to try to vilify, people who plagiarize and people who've copied someone else's code. I'm not trying to vilify or shame these students. I think these students just have gotten mixed up in terms of they lost sight of seeing that the homework, the purpose of the homework is to make them stronger and better. And they just got mixed up and believe that the purpose of the homework is to accomplish some kind of task. And again, that would be kind of like mixing up the purpose of going to the gym is not so that the weights get lifted, but to get stronger. All right. So anyway, my expectations is that you work hard, that you're going to try to do your own work. And I want you guys also to be okay with the idea that if you were not capable of completing a homework assignment to 100%, okay, that you're okay with submitting what you're able to do. And be okay with that. Okay, this is not a reflection of you being a failure, but just a reflection that at this current state and time, this task was a little bit too challenging to you, and it's just that with more practice and more time, you'll get better and you'll get there eventually. Okay, no one, at the gym, no one's going to shame you for not being able to lift the super heavy weight. It's just at some point in the future, maybe you'll be able to do it. Okay. All right. I got a bunch of slides that talk about what's allowed and what's not allowed. It can all kind of be summarized with, if it's a homework question, don't show each other your code. Don't post your code. As far as Campus Wire's discussion goes, there's a lot of ways to answer people's questions without necessarily asking for code directly and not necessarily posting code directly, right? You can answer. So you can say, I used this function. This is kind of the approach I used, without actually writing out the exact code that you've written. There's a lot of ways to answer things without kind of breaking this rule of don't post the code directly. And then if it's a question that's not related to the homework, right? Because I write a lot of code in my slides. If it's not a question directly related to the homework, you can copy that code, you can post that and ask questions about that. That's no problem. Okay. Take care of your health. Your physical, mental, spiritual, and emotional health is going to be far more important than your grades. And so, please take care of yourself. I know it's difficult, especially with kind of this. We're still in quarantine, lockdown, and social distancing, physical distancing. So I hope you guys still stay kind of connected to one another, still meeting, if not in person, I'm not encouraging meeting in person, but just even online, to have Zoom calls and chat and connect with people. And, connect with family, connect with your friends. Okay. I see myself, my responsibility as, to be your teacher, but I'm also here to try to support you as well. So, and if you get sick or something happens, let me know. I'll try to be flexible within reason. Okay. And we'll see. Okay. I don't know if anybody has any questions before we go on with kind of content, kind of this introductory content here. Okay. Oh, and just so you know, I have two screens going on. And so when you see me kind of looking off to the side, I'm looking at the slides that I'm presenting to you. And then when I'm looking here, it's because I got your faces right here. And so I'm looking at you when I'm looking at this screen, and then I'm looking over at the slides when I'm looking over there. All right. What is this class about? This class is titled Monte Carlo Methods. And Monte Carlo methods can be summarized as using repeated random sampling to estimate a numeric answer to a problem that would otherwise be difficult to answer analytically. All right. So with Monte Carlo methods, we're going to get estimation via randomization. That's kind of like your sort of rhyming short definition. But we're going to use random simulation to get an estimate of some kind of answer, an answer that would generally be difficult to answer directly. All right. You're going to get the history of Monte Carlo methods, rather fascinating. Okay. It was developed by this man, Stanislaw Ulam, who was working on the Manhattan Project. So when they were trying to design the atomic bomb during World War II, at the Los Alamos National Laboratory, this is when they came up, they developed Monte Carlo methods. Basically, in the calculations, they were trying to figure out, how much uranium would be needed, how much of this nuclear radioactive stuff would be needed, and trying to figure out the calculations for the yields and stuff. The conventional mathematical methods, they were having a lot of difficulty because there's a random element, when you look at kind of nuclear decay and things like that, there's randomness involved. And so drawing the calculations was quite hard. And he was inspired by kind of a question that he had when, I guess there was a time when he was sick and bedridden, and back then, when you got sick, you kind of just played card games, solitaire card games by yourself in bed. And he was playing this card game, and he just had the question, what's the probability that a game would be winnable? And he was trying to think of how to answer this using the calculations, which might be possible doing combinatorial calculations, but it turned out to be really, really, really hard to do. Okay. And he just thought, well, maybe I can't do the calculations, but maybe I can just deal out 100 random games to myself and play them out and just see what percentage of games I win. Okay. And whatever percentage, if he deals 100 games and he wins 60 of those games, then the probability of winning a game might be something around 60%. And so this was kind of his, the idea of just getting to estimate a win percentage without actually doing the math. And so he kind of explained this idea to his colleague, von Neumann, who coded the method into the ENIAC mainframe computer. So this is like right at the beginning of starting to see computational methods being used. And anyway, because they were working on the atomic bomb, and it was like super, super highly secretive, they had to come up with a code name for this. And they used the code name Monte Carlo, based on the Monte Carlo Casino in Monaco, which is, kind of where James Bond goes to play Baccarat and stuff like that. Kind of inspired by this idea of just randomness and random things. And that name stuck around, and Monte Carlo methods have kind of been greatly expanded to kind of encompass any kind of time where you're using simulation and randomness to get an estimate for some kind of answer. So everyone's taken 100B. That's a prereq for this class. And, in 100B, you learn how to find properties of probability distributions. So for example, let's say we have random variable X random variable x has this PDF f of x, okay? How do you get the mean? What's the mean of this random variable, okay? Well, the in 100b, it's going to be the integral of x times f of x, right? You take the value x, multiply it by the probability of getting that value, you multiply it by the PDF, and you take the integral over all the possible values of x. So that's what this curvy x is. This represents kind of the support of f, okay, wherever the PDF is not 0. So if it's the normal distribution, it would go from negative infinity to infinity. If it's the binomial distribution, or not the binomial, if it's the beta distribution, it goes from 0 to 1. If it's the chi-squared distribution, it's 0 to positive infinity, you know, whatever it is, okay? So that's what it is for the continuous distribution. And if we're looking at a discrete distribution, instead of an integral, you have the summation, right? So if it's discrete, you have the summation from I to whatever value it is that x can take on, if this is countably infinite or something. So this should all be a review, right? From 100b. If you wanted to take the variance of a random variable, then you have sigma squared, which is the expected squared distance from the mean. All right, so the variance is the expected squared distance from the mean. And so you take each variable x and you take the distance from the mean, or x minus mu, and you square that. So this x minus mu squared is the squared distance from the mean, and the variance is the expected squared distance from the mean. So what's the expectation of this? This is just going to be x minus mu quantity squared times f of x integrated over all of x. If it's the discrete version, you know, you replace this with a summation, okay? And then I'm sure in 100b, you know, one of the kind of the most fundamental identities that you probably have to show or prove is that this expectation can also be broken down into this expectation, that it's the expected value of x squared minus the expected value of x quantity squared, and that would be equal to the variance of the random variable x. Okay, so this is just stuff from, this should all be review from 100b. And if you have just any arbitrary function g of x applied to some random variable, then the expected value of g of that random variable x is going to be equal to the integral of g of x times f of x. Or if it's a discrete, it's going to be the sum of g of x times f of x. Okay, and so this is, so, you know, that's basically it. Okay, so this big picture, all right, so if I just had to summarize what Monte Carlo methods comes down to, is that a lot of these integrals, they can get messy. They can get really complicated. Some integrals are impossible to solve analytically, and other integrals are just really hard to solve analytically, okay? And what Monte Carlo methods allow us to do is that rather than trying to solve and get an exact analytic answer, we can get an estimate, okay? We can get an estimate based on simulated randomness. And that's what the entire class is all about, okay? Don't worry, we got, I mean, we could end it here and you would have at least gotten the gist of what Monte Carlo methods is. We'll spend 10 weeks on it, okay? We've got 10 weeks to really develop some of the methods and, you know, give it a context in which we can apply it. But this is what it comes down to, is that the math gets hard. And so to estimate the answer, we're going to just basically run simulations and do random trials. So a very, very, very simple example is, let's say you have a random variable x, and you want to know what is the mean of my random variable, okay? What's the mean of my random variable? So what you can do, okay, if you are able, and I guess this is a big if, but if we can generate a sample of values drawn from this distribution, right? If we can just generate samples drawn from this distribution, then the mean of the random variable can be estimated using the sample mean, right? So all we have to do is just take a sample of random values. And if we take the mean of that sample, that can be an estimate of the mean of the random variable. Okay, and so that's all I have here. The estimated mean, mu estimated, is 1 over n of the sum of x. So the chi-squared distribution, all right? So what is the mean of a chi-squared random variable with 5 degrees of freedom? Okay, so what is the chi-squared distribution, or what is a chi-squared random variable with 1 degree of freedom? You guys remember? Chi-squared random variable with 1 degree of freedom. How is it related to like more?
It's a normal distribution squared, right?
It's just, it's a normal random variable squared. Okay, so you take one value drawn from a normal random distribution. Okay, so you have a normal random variable, and if you square it, you're going to get the chi-squared distribution with 1 degree of freedom. Okay, and what's the chi-squared distribution with 5 degrees of freedom? It's going to be the sum of 5 of these things. Okay, so you basically have these chi-squared random variables, and you add up 5 of these things. And so the answer to this, what's the mean of a chi-squared random variable with 5 degrees of freedom, is going to be 5. Okay, but to do this, the analytic approach, if you don't remember that kind of relationship, is you'd have to look up the chi-squared distribution. You'd have to look up the PDF. The PDF of the chi-squared distribution is this, okay, where k is the degrees of freedom. Okay, so you have 1 over 2, k over 2, gamma k over 2, x times k over 2 minus 1, e to the negative x, right? So you take this thing, you plug in k equal to 5 degrees of freedom, or whatever it is that you're dealing with, and this is review. You're not going to be tested on this, but in 100B, I imagine this is how you found like the mean of random variables and stuff, is that you might use something like the moment generating function. Okay, you guys remember this? And so the moment generating function of the chi-squared distribution is the expected value of e raised to the t times x. And you have this thing. This is the moment generating function. And then the mean is equal to the first moment, which is equal to the first derivative of the moment generating function. Okay, if I remember my 100B math correctly, I think this is what it's going to be. So you work through the first derivative of the moment generating function. You go work through this. You do it where t is equal to 0, and you get the answer. Mu is equal to k, the number of degrees of freedom. Therefore, if we have a chi-squared distribution with 5 degrees of freedom, our mean is going to be 5. Okay, and this is how we would go about answering this from the analytic perspective, right? And you guys all had to do this in 100B, and because 100B is all kind of like doing the mathematical and the analytic method for answering these questions, right? This is the Monte Carlo method. Monte Carlo method says, oh, I don't like doing this math. I don't like this analytic math stuff. I don't even need an exact answer. Can I just get an estimate? Okay. And you just need an estimate. It's very easy. Okay. So what you do is you just say, all right, let's generate a big sample. So here I've got 10 to the 5. So that's 100,000 values. And I use the computer and I say, I want some random chi-squared values. I want 100,000 random values drawn from the chi-squared distribution with 5 degrees of freedom. This is going to form my sample. And what is the mean of my sample? The mean of my sample is 4.993. Okay, so this is very close to the analytic answer of 5. Okay, it's an estimate. This is the Monte Carlo estimate, and our estimate is 4.993, which is pretty close to the analytic answer. We're not going to, so, a limitation of Monte Carlo methods is you're not going to get a formula for the analytic answer. You're not going to come down to this identity where you say, well, the mean is equal to k. That's not going to happen. You're just going to say, what's an estimate of the mean? The estimate of the mean is 4.993, okay? And you don't know if this is bigger or smaller than what it should be, okay? Here we can say we know that the analytic answer is 5, and we know this is slightly smaller than what it should be, but in real life, you would not know this. You would just say, okay, my estimate's 4.993. Maybe that's a little bit bigger. Maybe it's a little bit smaller than what it should be. And this is an easy way to get an estimate of the mean of the random variable. And that's what Monte Carlo methods come down to, is that we're just getting an estimate based on just generating a random sample. If we switch the question and we said, what is the variance? What is the variance of a chi-squared random variable with 5 degrees of freedom? Okay. Well, analytically, you could go through that whole process, right? You could use the moment generating function, and you'd have to kind of get the second moment and things like that, right? So you'd probably use this identity. You'd use the second moment to get e of x squared and things like that. And you can go through that whole process. And if you go through that whole process, it's going to come down to the variance is equal to 2 times the degrees of freedom. Degrees of freedom times 2 is going to be your variance. Okay. Monte Carlo methods, you just say, well, I've generated 100,000 values already. Let's just take the variance of that sample. The variance of that sample is 9.978. The true value is 10. My variance is pretty close to that. It's a little bit off, 9.9789, but pretty close to the actual value. And that's good enough for us, okay? So that's the thing. Monte Carlo methods, you're not going to get an exact answer. You're going to get an estimate, and hopefully your estimate's pretty good enough, okay? Here's some applications. These are real-life Monte Carlo methods going on right now, okay? So we have a presidential election coming up, okay? And so there's this website, 538, and they have an estimate of who might win the election, okay? And this, if you look at it, it says we simulate the election 40,000 times to see who wins most often, okay? And so as of today, when they did 40,000 simulations, okay, it shows Biden winning 79 out of 100 and Trump winning 20 out of 100, okay? So this is kind of this is the Monte Carlo estimate of who might win the election based on simulations, okay? And so because there's no math formula where you can just plug in information about the election and get some kind of answer. And so this is based on a simulated model. They have a model for how people might cast votes and things like that. And based on that simulation, which they simulated 40,000 times, they're getting an estimate. Okay. Similarly, right now, the NBA finals are going on, and I'm a Lakers fan, so this is very, very exciting for me. They're looking at who might win the championship. Okay. And it says these forecasts are based on 100,000 simulations of the rest of the season. So they have some kind of computer model of a simulation where they kind of play out these games. And based on the 100,000 simulations that they're running, they get an estimate of who might win, okay? But this is, it's based on a simulation. In 102A, one of your homework assignments was to simulate the board game Monopoly. If you took 102A with me, I had you guys simulate moving around the Monopoly board. That is a Monte Carlo simulation. Okay, there is an analytic approach that you can take to estimate the probability of each space being landed on. You can find the exact probabilities of the dice rolls and the exact probabilities of transitioning from one space to another space. But another approach was to write the code for simulating board movement and then running that game, that code, 100,000 times or whatever it was, and you get an estimate of the probabilities of landing in different spaces. Okay, that's a Monte Carlo method. Okay, where we are trying to estimate some probability or some kind of answer based on simulation. There's a bunch of Monte Carlo methods in finance as well. Okay, where they kind of use simulations to or randomization to simulate, the price fluctuations of different commodities or stocks or different things like that to kind of see, what kind of bigger impact this might have. So a lot of it is building up simulations. And so, where we're headed in the course is that Monte Carlo methods, I would say Bayesian statistics these days is made possible because of Monte Carlo methods. So Bayesian statistics has become a lot more popular in the last couple of decades because Monte Carlo methods have made the analysis possible. The concept of Bayes' rule and stuff has been around for a couple centuries, but the analysis has become a lot more popular because the math involved in Bayesian statistics gets really complicated. There's going to be integrals and they get hard, okay? And Monte Carlo methods allow us to get estimates without having to deal with those hard integrals, okay? You also have high dimensional settings where the math gets really messy, okay? And again, Monte Carlo methods allow us to get estimates in these situations where the math gets too messy to try to solve analytically, right? And so, so that's what this whole class is about, right? And so next week, starting on Monday, so no homework over the weekend, but on Monday, I'll give you your first homework assignment, and it's going to start dealing with, I'm going to introduce Bayesian statistics. So we're not going to just jump right into Monte Carlo methods right away, okay? We're going to start with Bayesian statistics, and I'm going to start you off with kind of a foundation there to kind of give you a context for all of this work. And then we'll talk about Monte Carlo methods, just using R's random number generators. So you saw me use R chi-squared and stuff, and R has a lot of built-in random number generators. We'll talk about creating kind of our own, or being able to create random numbers from different distributions that have, strange distributions. And then from there, we'll build up on that. And we'll get into Markov chains and Markov chain Monte Carlo, which is a really powerful method as well. And specifically, we'll look at kind of the Metropolis algorithm and Gibbs sampler. And that'll kind of fill out the 10 weeks. We'll have, and along the way, we'll stop off with some interesting applications of these things. So that's kind of the plan for the course. Let me give you your second and third quiz answers, and just give me a minute to create the viewing quiz. I gotta kind of go through and create these things. So your second quiz answers for today will be C and A, cat and apple. Okay, so your second and third quiz answers will be cat and apple, and that's for your viewing quiz. I look forward to this quarter. Thanks for those of you who turned on your cameras. It's really good to see your faces, and I hope this quarter goes well. I wish we were in person, but it's much safer and better this way. So hope you guys are doing well, and we'll see you guys on Monday. Have a good weekend. And I guess technically I'll also have office hours today at 1 o'clock. So I'll sign back in right here. So see you guys, and have a good weekend.